Good day everyone. Today we're going to discuss our group study which is about the operational amplifier, and our discussion is focused on cascaded operational amplifier configuration, which is a head-to-tail arrangement of two or more operational amplifier circuit such that the output of the first stage would be the input of
This
the
is our
next.
problem number 1, and this is the configuration. And we are going to solve for voltage 1, 2, and 3. So the first step is the summing amplifier. So here is the model of the summing amplifier, and we have here a formula which is for the output voltage 1, negative RF times V1 over R1 plus V2 over R2 plus V3 over R3. We'll just have to substitute all the given values here and we'll arrive at the answer, that is negative 3.6 volts. And the second step will be the inverting amplifier, and here is our model. And the following is the formula for the inverting amplifier. Output voltage 2 is negative RF times V1 over R1. And again, substitute all the values, negative 2.4 kilo ohms over 200 ohms times 500 millivolts. The answer will be negative 6 volts.
Now we are going to solve for the last stage of problem number 1. And we are going to solve this using the nodal analysis. First step would be redrawing the operational amplifier with its corresponding inputs, which we solved earlier. And those are negative 3.6 volts and negative 6 volts. And nodal at B is going to be I1 plus I2 is equal to I3, shown by the arrows in here. And substitute all the values right in here. Since it is a current, negative 6 volts minus VB going to this node over resistor 500 ohms minus 0 minus VB over 5 kilo ohms, we will arrive to the answer VB is equal to negative 5.45 volts. And as per general rule in the analysis that we are doing, voltage in node A is going to be equal with VB that we solved, which is negative 5.45 volts. And nodal at node A, I1 plus I2 is equal to I3, where I3 is equal to 0 again. Negative 3.6 volts minus VA over 1 kilo ohms minus V out from here minus VA over 10 kilo ohms, and the final voltage output or output voltage is going to be negative 24 volts.
Okay, next is problem number 2. So here we have the combination of summing amplifier and then the voltage follower. So the values are given, R1, R2, R3 is equal to 50 kilo ohms, and the equation of the voltage is given. Next, we will now solve for the first stage. We will computation of voltages. V1 is equal to 0.5 V2 is equal to 2 V3 V1 is equal to 2.2 here. And then to get the V2, it is 2 times 2.2 volts equals to 4.4. And then the V3 equal to 2.2 volts over 0.5 volts. It is equal to 1.1 volts. And then here we will use the summing amplifier formula to get the output voltage. Negative RF multiplied by V1 plus V2 plus V3 over R. So just substitute the solved values here, and then we will get the output voltage negative 30.8 volts in the first stage.
So I'm going to discuss the stage 2 for problem number 2, which is a voltage follower amplifier. So since the circuit of up is in a voltage follower's configuration, its output will be equal to its input. So VO is equals to VI. Hence, its input is the output of the first stage as per the general rule of cascaded configurations. Therefore, the final voltage output is equals to the stage 1 voltage output, which is negative 30.8 volts.